Hello everyone, I am Rupam Maiti and welcome to this new video. Today we are going to look how to measure power in a single phase circuit. Single phase means where there is one single source of supply. There are basically two methods. One is by using 3-voltmeter, so it is called the 3-voltmeter method, and the other one by using 3-ammeters, so it is called the 3-ammeter method. In each case, we will be looking at the circuit diagram, how to draw it, the phasor diagram of the circuit, and derive some basic related formula. So, it is going to be an exciting session. Let's start. So, the question is, how do we measure power, which is an important electrical parameter in a single phase circuit? As I told, there are two methods, the 3-voltmeter and the 3-ammeter method. How can we draw the circuits? We have a single source of AC voltage, one known resistance, test resistance or known resistance, and to which this load is connected in series. Here we are considering an inductive load. Here we are considering an inductive load which has some inductance L and a few and a resistance R load. Here this one I told you that this is the known resistance R. Now the 3-voltmeters are connected as like this. One is connected across the AC source itself. Let us call it V1. Another one is connected across this known resistance R, let us call it V2, and the final one is connected across the load, let us call it V3. Right? This is the circuit diagram of the 3-voltmeter method. Pretty simple, right? 3-voltmeter. We can draw the circuit diagram of the 3-ammeter method. Here also we have one single phase AC source and 3 ammeters connected as follows. Like this. Excuse me for my bad drawings. I am getting accustomed to it day by day. So here we have one ammeter. Let us call it A1. The ammeter measures the current which is supplied by the AC source I1. Second ammeter A2 is connected in series with the known resistance R, and the last ammeter is connected in series with the load, which is an inductive load. It has a component R load and a inductive component of inductance L. This is the 3-ammeter method circuit diagram. Okay, we'll be looking these two methods in details. The 3-voltmeter method. In 3-voltmeter method, as we have seen, we use 3-voltmeter and a test resistor whose value is known to us. Let me redraw the circuit. Please try to draw and have a practice. Let me draw a So we have one known resistance here, one voltmeter connected here, and the last connected across the load V1, V2 and V3. Resistance of the load component is R load and inductance is L. We can draw the circuit diagram by assuming that the load is inductive. So a current flows in the circuit I. As it is a series connection of these known resistance R and this load, so we can take the current as the reference axis I. The voltage across this known resistance R V2 is in phase with this current because the voltage across a resistor is in phase with the current across it. So this voltage V is in phase with this current. Now the voltage across the load V3. V3 voltage should be leading I. Why? Because V3 is basically the voltage across the load and our load is inductive. And we know that across an inductor, the current lags the voltage by 90 degree. But that would be in case of a pure inductor. Our load here in this case is not a pure inductor. It is not a pure inductor. It has a component of resistance in it, which is R load. So the current will be lagging the voltage, but not exactly by 90 degree. Somewhat between 0 to 90 degree, somewhat like this. We can call it V3, right? And from the circuit, we can say that V1 here, the voltage across the supply, is the phasor sum of V2 and V3. So phasor V1 should be pointing like this. Clear? We can draw the phasor like this. Let me tell that the angle between the voltage V3, which is the voltage across the load, and current I. So what is phi? Phi is nothing but the angle between V3 voltage and I current. Basically, we are considering the voltage and current across the load. Voltage and current across the load, which is an inductive load, not a pure inductor, but an inductive load, impure inductive load. Voltage and current across the load. The angle between them is phi. Now here let me write, it will be easy to understand that the V1 is the phasor sum of V3 and V2. By applying the formula of vectors, we can write V1 square is equals to V2 square plus V3 square plus 2 V2 V3 cos phi. Clear? As V1 is the phasor sum of V2 and V3. So we can write this relationship. Clear? So we have V1 square is equals to V2 square plus V3 square plus 2 V2 V3 cos phi. We have already defined the angle phi in the previous slide. From here we have cos phi is equals to V1 square minus V2 square minus V3 square upon 2 V2 V3. This is an important relationship. Now let us talk about the main parameter, that is the power. Now what is the power across load? Load power, how can we write it? Vi cos phi, the voltage across the load V3, the current across the load, and the phase angle and the power factor cos phi. From here we can also write, can you see, we can also write this relationship which we got in the previous step. We can write this is the power factor of the circuit, this is the power factor of the load, power factor of load. So we basically have the formula for the power factor, which is V1 square minus V2 square minus V3 square upon 2 V2 V3. Let us substitute this value here. Okay, let me mention one more thing here. In the previous slide, observe carefully in this part. What we can say about the relationship between V2, R and I? We can say that I basically means V2 upon R. Simple Ohm's law. I is equals to V2 upon R from this voltmeter and resistance reading, where voltmeter shows me the reading, voltmeter V2 shows me the reading, and I've already told that R is the known resistance test resistor. Okay, so we also have I equals V2 upon R. Let us put all these values in the power formula. So what we have, V3 and I we can write as V2 upon R and cos phi, which is V1 square. I'm just putting the values derived up. Clear? Here the V2 and V3 term get cancelled, and finally we have 1 by 2 V1 square minus V2 square minus V3 square upon R. So we have derived the power. Let me write in different color, it would be visible for us. So what we have derived till now? We have derived two important things, that is the power factor which is cos phi, and it is given as V1 square minus V2 square minus V3 square upon 2 V2 V3, and we have also derived the power consumed by load, the power consumed by load, which we can write P, which is equals to 1 by 2 V1 square minus V2 square minus V3 square upon R. Here a small mistake, it would be V3 square. So we have these two important formulas. It is easy to remember. You see, it is easy to remember how uh, in previously we all know that power is given by I square R, or is equals to V square upon R. So the form, just keep in mind the form V square upon R. The numerator has a voltage square term. Here the voltage square term is like this, and the denominator has a resistance term. Here also it has a resistance term, and 1 by 2, this constant is extra. So We can remember it 1 by 2 half of V1 square minus V2 square minus V3 square upon R. The voltmeter gives us these readings V1, V2 and V3, and we already know the resistance value R. We put in the values and we get the power consumed in a single phase circuit. Also, we get the power factor, and accordingly we can improve the power factor to get the maximum power. Nice, nice and clear. Okay, let us now look at the second method, which is the 3-ammeter method. Here, as we have seen in the circuit, we use 3 ammeters and one test resistor R. How they are connected? There is a single phase AC supply and 3 ammeters like this. Okay, ammeter A1 is connected in series with the supply. Ammeter A2 is connected in series. Ammeter A2 is connected in series with the known resistor R, and A3 is connected in series with the load, which is an inductive load which has a resistive part R load and a reactive part or inductance part L. Here we can show the currents flowing in the circuit as I1 is given out by the supply, which is breaking here at this point into two components, I3 and I2, and flowing like this. So we can say that the resistance R and load are in connection parallel connection. Clear? Are in parallel connection. We can simply see from the circuit. Let us try to draw the phasor diagram. Let us try to draw the phasor diagram for the same. How could we draw? As it is a parallel connection, so we will take the reference as voltage remains the same across the two branches of the parallel connection. Let me draw with a deep color, say blue. Okay, so the voltage here is V, which is supplied by the AC supply. The current I2 is flowing through the resistance R, and the voltage across this resistance is also V. So we can say that V2 and V and I2 are in same phase. Why? Because we know that voltage and current across a resistor are in phase, right? And here across the load, the current lags the voltage. We can say current I3 is flowing across the load here, so I3 lags the voltage V across the load. Why? Because we know across an inductor the current lags the voltage by 90 degree across the pure inductor, but in this case we don't have a pure inductor, we have a resistance component in it. So we can roughly say that current I3 will lag the voltage V by some angle. So the current I3 will be in the downward direction from the voltage V. This is current I3. And from the figure it is clear that This is I1 current. Current I1, which is given out by the supply, is the phasor sum of I2 and I3. Clear? So we can draw simply the I2 and I3 current. We can add them and we will get roughly a current I1 like this. Clear? It's very simple. Clear? Let me call the angle between the voltage V, this voltage, and the current I3 as phi. We are basically calling phi the angle between, same treatment as we have done in the 3 voltmeter method, angle between voltage V and current I3. Why these special parameters? Because they are the voltage and current across the load. They are the voltage and current across the load. You can also say from this phasor diagram that I1 is the phasor sum of I2 and I3. So we can easily write from here the relation that I1 square is equals to I2 square plus I3 square plus 2I2 I3 cos phi. This is simply the vectorial sum formula. I1 square is equals to I2 square plus I3 square, the two components, plus 2I1 I3 cos of angle between them. So we have I1 square is equals to I2 square plus I3 square plus 2I2 I3 cos phi. From here we can get the value of cos phi as I1 square minus I2 square minus I3 square upon 2 I1 to I2 I3. This is nothing but an important formula. It is the power factor. What is this? This is the power factor of the load. Power factor of the load. We have derived the formula to find the power factor of the load, cos phi. Okay. Now see here, in this segment of this circuit, what we can say? We have current I2, the resistance R, and the voltage V. We can easily say that the current I2 is equals to V by R from Ohm's law. So we have to keep in mind this formula also. What? That I2 is equals to V by R. Now what? Now the important thing we are looking, the power consumed by the load, which are intended to find out power consumed by the load. What will be that? It is nothing but the voltage V across the load, the current which is across the load, here in this case it is I3, and the angle between them, cos of angle between them, which is the power factor cos phi. Vi3 cos phi, Vi3 cos phi. Now simple job is left, that is putting the value here. We can write V as I2R, put it here, I2R into I3 into cos phi, which is derived above I1 square minus I2 square minus I3 square upon 2I2 I3. The I2 and I3 terms get cancelled out and we have 1 by 2 I1 square minus I2 square minus I3 square into R. So we have derived these two important relationships, that is power factor which is given as cos phi, and its formula is I1 square minus I2 square minus I3 square whole upon 2 I2 I3. I'm just summarizing these points, okay, for your benefits. And another important relationship, that is the power consumed. Power consumed by load, which is equals to this one, 1 by 2 shortage of space, 1 by 2 I1 square minus I2 square minus I3 square into R. It is easy to remember, as in case of 3-voltmeter method, I told you already that power we have already learned comes in these types of relation, I square R, V square upon R. Okay, in the voltmeter method we saw this form was applicable, and now in 3-ammeter method we see that I square upon R, I square into R, I square multiplied by I. See, I square term is there, this is the I square term and this is R. Of course there is one constant 1 by 2. It was also there in 3-voltmeter method. Half of this term multiplied by resistance. So the values of I1, I2, I3 is displayed by the ammeters, and the resistance value we already know, the test resistance, so we know the value of the resistance R. We get the power consumed by the load. Okay, thank you. This is for today's video, and remember, dreams don't work unless you do. See you in the next video.